We are back on the New York State Education Department Computer Science and Digital Fluency Learning Standards page. On this page, we are going to scroll down. We're not going to actually grab that first link this time. We're going to scroll down to the Computer Science and Digital Fluency Standards 4 through 6 document. While it is good to look above and below to see what the standards are asking as they're being scaffolded, for the sake of this video and for us to take a look at what the standards are asking for grades 4 through 6, we're going to use this document for the rest of the from the rest of the concept areas. I'm going to scroll down to the table of contents and then click on computational thinking, which will take me to page 4 of this document. Computational thinking is the largest of the concept areas in that it has 10 standards that we need to address in the course of grades 4, 5, and 6. There are 4 sub-concept areas that you can see down the left-hand side of your screen. The first one, CT1, is develop a computational model of a system that allows changes in input when there are changes in output when there are changes in input. So here we're thinking about how our simulations change based on input and output. As we move into data analysis and visualization, we're collecting digital data related to real-life questions. We want to bring that into current events or things that matter to our students. And the emphasis should be on using digital tools to collect that information and organize the data. We then want to visualize a simple data set in order to highlight relationships and persuade an audience. So when we're doing this standard, we may have the students create the data and then use their data to create a persuasive essay or, convince their classmates to do something. As we move to abstraction and decomposition, CT4, decompose a problem into smaller name tasks, some of which can themselves be decomposed into smaller steps. Here we're looking at the small parts of what makes a whole or the steps that we need to complete something. So it might be having the students figure out the fastest way to get from their desk to the hallway, or think about how they have to put together a recipe or something along those lines. For CT5, you're identifying and naming a task within a problem that gets performed multiple times when solving the problem, but with slightly different concrete details each time. So the focus here is recognizing some of the things that are often repeated, so you're creating those loops, even though some of the details might differ. Finally, we have algorithms and programming, which is the largest sub-concept area that is within computational thinking. For CT6, we're going to be comparing 2 or more algorithms to talk about the advantages and disadvantages. These can be unplugged, or you can do them on the computer. So you could do some basic coding, or you could have your students doing origami or putting together recipes or how-to books. As we get into CT7, we're identifying pieces of information that might change as a program or process run. The focus is really identifying information that needs to be updated as computation progresses. So this might be changing a variable in their math problem or assuming some information and then finding out some more information as they're learning more. With CT8, we're developing algorithms or programs that use repetition and conditionals for creative expression or to solve a problem. The focus here is working on conditionals, so it could be an if-then statement or repetition like a loops or iterations, but without having to use them in conjunction with one another. So really, this is a very base foundation for understanding computer programming. As we get into CT9, explain each step of an algorithm or program that includes repetition and conditionals for the purpose of debugging. So your students write an essay and realize one of their steps is wrong, or they are folding something into origami and they realize something is wrong. They write an essay and there's a sentence that's confusing to the reader. They have to debug to be able to make sure that it is readable and has less errors. And then finally in CT10, we're describing the steps taken and choices made to design and develop a solution using the iterative design process. Iteratives just means we're going to try more than one time, right? We're going to persevere through the information to try to figure it out. An iterative design process involves defining a problem or goal, developing a solution or prototype, testing the solution or prototype, and repeating the process until the problem is solved or desired result is achieved. Describing can include speaking or writing. Here we're really talking about the engineering or the design process. So that is computational thinking. I highly recommend that you take a look at these standards more in depth and think about how they would look in your classroom.